So results are actual statement of observation, including statistic table and graphs. So I have actually stressed on that you should talk about the actual observation. Yeah, what do you observe for your results when you put your data in a form of tables, in a form of graph, pie charts, or you have photos from images from FISM or HRTM, you have GCMS, you have Raman spectra, or you have NMR spectra. So you need to tell the actual observation. So try not to be influenced by someone else's work. First, we describe our own results. We describe our own results. Do not try to change the observation or the trend according to someone else's result, okay? But if you find it that your results are a bit weird, okay, what do? You have obtained the data, but when you obtain the data, you do not have the the output. You do not have the opportunity to think about the trend. So, but in the end, when you plot a graph, then you have the trend, and it seems that the trend is weird. So what do? Now this is practical. So what do? Any suggestion? Okay, any suggestion? Anyone? Okay, so I think one of the best way is to sit down with your supervisor first. Do not throw any negative results. I do have students who actually were not convinced with the result, so he she just threw it away. So when I found out that happened quite some many times, so I think this is such a waste. Results, even though it's positive or negative, or you think it's weird, you should make it in proper form and discuss it with your supervisor. And let's say your supervisor, let's discuss with another expert. So do not just throw your results when you think that the results are all weird. Okay, you have to sit down first, talk about it, okay, discuss it, because sometimes you cannot see the one that you probably it is correct, but there's something wrong somewhere. Okay, so even though you need to improve, for example, or you might have to replot. You might have to replot. So just don't throw away your data, but sit with your supervisor and talk about the what can you do with these results. So we have discussed that thesis is evidence. Is evidence that you are going to present to jury, the examiners, to support your hypothesis. Okay, you have a hypothesis at the beginning, and now you have the evidence. Okay, all right. Present sufficient details so that others can draw their own inference and construct their own explanations. Yeah. So this one is quite. It's just a very theoretical. Yeah, lay out the sufficient. But just imagine that you want to defend your findings, and you have at the beginning decided that you want to do something, and you propose the method, and you propose your idea, and you carry out the experiment, and now you have the data, and then from your observation the data does support your idea, and you explain to the examiners. Break out your results into logical segments by using subheads. Okay, if you do not know, if you don't have any ideas because your work is very new, talk to your supervisor. They have a lot of experience, and they should by right know how to organize your thesis. So supervisor must play a big role in helping you writing your thesis. Of course, if that kind of work has been done by seniors, previous researchers, then usually the structure is known, yeah. But it can be the work that is not common, okay, it's new. So how do you put it in a report, okay? So that when people read it, it's easier for people to be convinced and understand, okay? So that's what I mean when you talk about the discussion or the organization of thesis. The organization of thesis is very important, because if it is not well organized, it's very difficult for the reader to understand. Yeah. Okay. So in discussion, so very important. Okay, just now that I mentioned negative results as well positive result. Just put it there first. Okay. Discuss with your supervisor, and then discuss on what to do. Whether this result is actually showing something else, don't put it away yet. And then later, if you really decide that it's very dangerous for you to put it there, then okay, with your supervisor's consensus, then you put it away, okay? Right, so I remember that I said that results and discussion section, so it's not just telling the trend, okay? For example, if you have the graph, the trend is going up, then you say, okay, the reading is increasing, the whatever is decreasing. You need to discuss it, yeah? Of course, we start with patterns, observation of the results that you obtain, yeah? The observation. So you look at the graph, you look at the bar chart, you look at the pie chart, or tables, data in tables, and discuss the patterns, okay? So if it is should be getting bigger, then it should be increasing or decreasing, then you tell the pattern first. Start with a few sentences that summarize the most important results, okay? This discussion section should be brief essay in itself, okay? So try not to, for me, I think, try not to write too many because you want to make sure that your thesis is thick. It's not always that way, okay? But what we want is a very not to say precise, important points to be discussed. Yeah. So it doesn't have to be long, but you highlight the most important. For example, if you observe that with the increment of temperatures, you obtain a lot more yield, then you should discuss why, okay? Let's say you want to come up with a formulation for drug delivery. The best formulation is with certain ratios of starting materials. So you discuss that. So with these starting materials, why do you have, let's say, A as starting materials, tend to have more yield compared to having C as starting material, for example. Yeah? And then let's say you have stated the observation and the pattern, okay? And then what are the likely, okay, you should also, when I say the chemistry, because we are talking about chemistry, the chemistry behind, okay? So if you, for example, do pH effect, yeah? You study the pH, and then you find that at acidic pH, it tends to have optimum or better results compared to basic pH, yeah? Alkaline pH. So the observation will be, okay, more product is produced in the acidic compared to alkaline or basic range. So it's not enough for you just to talk about it. So you have to tell, okay, there is likely a protonation, H plus, okay, that cause whatever. So since we are in chemistry, So we have to talk about, for example, hydrogen bond, the effect of H plus, protonation, that give the that supports the idea of why the production is greater in acidic range. Okay, so the pattern and then the Y factor. And then the third one that should be in the discussion as well, is there any agreement or disagreement with previous work? So it's not always necessary to have this sometimes. It's not always necessary because sometimes your work must probably is a new one. So not many have data on this, but it is good if you do not have previous work, you at least support the data based on theory. Okay, any theory, thermodynamic, kinetic, chemistry that you know can support the idea or the, sorry, not the idea, the observation of your, the trend of your results. So if you cannot find previous work that is related, so you have to use the laws, the theory in chemistry. So that's why we learn all these theories that you learn from separation chemistry, solid states. So this is the time that you put all the knowledge inside the discussion. So the three structures that is very important in discussion, in result and discussion, is writing the pattern of your results, observation, and then likely mechanism. Okay, why the observation is that way. Any disagreement or agreement to corroborate your finding. So you can also, not necessarily from previous work, but you can also support it with textbook material, because this is the rules according to first law of thermodynamic, for example. Okay, so you can support by using that. Interpret results in terms of background laid out in the introduction. Okay, so what is the relationship of these present results to the original question? Okay, of course, when we design the methodology, we design it so that it is answering the objective. Objective means that what you want to achieve. So I think it should not be any questions, because the results obtained is based on the methodology section. And then whenever that you discuss the result, it should tailor to support the objective section. Okay, so if your objective is to optimize the formulation of the nano delivery, as for example, then it should be, the discussion, it should be supporting the objective of getting an optimized formulation. So let's say you are developing a new biofuel, okay? And of course, your discussion is based on the specific specific characteristic of biofuel that you want to achieve. It must be certain specific quality as well as characteristic of biofuel that you want to achieve. Let's say you are doing something related to photocurrent, solar cell, for example, solar cell. So there must be certain threshold value that you want to achieve to say that, yes, whatever work that you have done to modify the solar cell has achieved certain level. Okay, it might be not as good as probably in the commercial, the same level as the one that is commercially available, but you might have achieved 50%, 75%. So you need to know what are the characteristics or what are the parameters that you actually want to achieve as threshold values to be saying that you have achieved this objective. So what is the implication of the present results for other unanswered? Okay, if this one is there, it's fine. Okay, and then of course you have hypotheses. So you are trying to answer your hypothesis. What are the things we now know or understand that we didn't know or understand before the present work? Of course, this should be in the thesis because research or dissertation, we want to do something that we do not know. It's not doing something that we already know. Okay, so that's why we pose the questions and try to answer the questions. Okay, so include the evidence or line of reasoning supporting each interpretation. Okay, again, the evidence must be in the result itself. Try not to be biased. Okay, if it is not supporting the supposed to be theory, then you I will not be saying anything, but you need to sit down and talk to your supervisor. Why is this happening, and what can we do on that matter? Okay, all right. This section should be rich in references, of course, to similar work and background needed to interpret results. Okay, so this section should be full with previous work, citation, and background means that the theories, the laws, the knowledge, the textbook material needed to interpret results. However, interpretation, okay, are often too long. Okay, is the material does not contribute to, okay, says me right. All right, it's organization of thesis. Okay, so I just continue with conclusion because it's not much in conclusion before we move on to example of chapter 4. So of course, whenever that I show example, of course it's not the best, but at least you know the real example of the thesis. Yeah. So conclusion, what is the strongest and most important statement that you can make from your observations? So what is the strongest and most important? So you have to decide. Okay, you have to decide because you already know what you want to achieve. So this is where you want to tell again the reader to highlight again the most important. Okay. Okay, so it's good point. If you met the reader at a meeting 6 months from now, what do you want them to remember about your thesis or report? So conclusion plays a big role. Okay, refer back to problem posed. It means that when you want to write conclusion, you have to refer back to the problem posed and describe the conclusion that you reach from carrying out this investigation. Summarize new observation, new interpretation, and new insights. Okay, so you don't actually put results in conclusion, but you are telling them what is your achievement, what you have achieved from your dissertation, from your research, what you have achieved, what new knowledge that you think that you have obtained. So that should be in your conclusion. Yeah? Do not repeat word for word the abstract, introduction, or discussion. So usually introduction is fine, but of course it's not word by word, and as well as abstract, because abstract contain results, very important results, usually the numbers itself. Okay, so for example, limit of detection, the numbers itself, but in conclusion we do not say exactly the numbers. Let's say I'm not sure whether you understand when I say limit of detection, you usually represent the sensitivity. So let's say in abstract, we usually write the actual one. So based on this, we have obtained limit of detection at picomolar, for example, 3 times to 10 to the power of negative 12 molar. Okay, so that will be in abstract. But in conclusion, we do not repeat the numbers, but we actually say it. Okay, we have obtained a very good sensitivity at picomolar, which is much better than blah, blah, blah. Okay, right? Okay, so you do not need to put the values inside the conclusion. Unless it is very necessary, you want to really highlight, then you can highlight again the values. All right, so recommendation is for me, I think it's quite easy because you recommend to people what have not been done and you think that should be done. Remedial action to solve the problem, further research to fill in gaps. Now that you have done for quite some time, so you know it should be done this way, should be done that way, but you don't have the time to do it. So now it is the time that you recommend people to do it. Directions for future investigation on this or related topics. Okay, so recommendation. I'm happy when I write recommendations because this is what you want to do it, but we do not have the time, we do not have the money, but we think that these are good things that should be done. Should be done to achieve the goal. Right, references. Okay, I will not be talking about references because now you should know if you went to the training by the library, should know about this software so that at this stage you can just put in all the references in the software, so one day you can generate the list. Do not ask me because during my time there is no software. I have to do it manually, all the commas, all the full stops. Okay, it was very tiring. Okay, but now you have software to do it. Yeah, to make sure that you follow the proper format. Okay, so appendix. This is, for me, this is wrong. Include all your data in the appendix. Okay, you do not need to put all the data in the appendix. Most of the data should be in chapter 4. Unless you have so many, for example, if you run so many GCMS, so many NMR, that if you put in the chapter 4, it's going to be, it's not nice. It's because you have too many. So that one you can put in the text in chapter 4, telling that certain data are available in the appendix, but you have to tell the reader that it is in appendix. Yeah, you do not expect the reader just to check appendix. Let's say what is in appendix, what is in the appendix. You have to write it, tell the people where to refer in appendix if there is a need to look at it. Okay, reference data materials not easily available. All right, okay. Tables were more than 1 to 2 pages, calculation were more than, okay. Again, this is sometimes we call it supplementary data. So tables, if the tables are too long, so put it in appendix. Calculations, because sometimes you just put the final value in results, but you do not show the calculation. But you have to show the calculation example at least in the appendix. How do you get that value, the final value? You, of course, have to put the formula in chapter 4, but usually we just table it and then the final value is in the table. But for me, curious readers, because examiners has to be curious, how do you get the value? So that's why you have to put example of calculation, at least 1 or 2, under appendix, so that you know the reader or the examiner will find, okay, you have done a correct calculation. Yeah? So you may include a key article. Usually this is, I don't know, during my time has never come across reference journal in appendix. Yeah? If you consulted a large number of reference, but do not cite all of them, you might want to include. Usually it's not done. Usually you have to list all the references in reference section. Also, equipment, I have never come across equipment put in appendix. It's always in the method section. Figures and tables. including captions, should be embedded in the text and not in appendix, yes, unless they are more than 1 to 2 pages and are not critical to your argument. So the keywords are, if it is not critical results, you find it, it can be sort of very boring, flipping through NMR, so many GCMS, then you can put it in appendix, provided that you tell them where to refer. Okay, so this will be the last section of your thesis, apart from biography and any other information that is required by university. Okay, definitely proofreading is a must. Okay, so if you have problem with your English writing, then you have to send for English editing. Okay, proofread your thesis a few times. This one is by you. Okay, or you can somewhat. So I think that's all for thesis writing or report writing in your case, because you are just doing a short dissertation. Okay, so if you have any question, just tell me before I share. Okay, I would like to share the example. Yeah. Okay, let me just. Okay. Okay. So I hope that you can see the chapter 4. I'm still using the same students example, the same title. Okay. So I hope that you still remember that the title is on development of diagnostic for dengue detection. Okay. Right. So at the beginning, he discussed about the gold nanoparticle that he synthesized. So you can see that he started with a bit of introduction, okay, telling this is just like, you know, to make it people want to read. Okay, so it's not really nice if you just, okay, based on this the UV analysis directly, based on the UV analysis. So this is just slightly the way how you can write to have an introduction. So the synthesis was based on original method. Okay, just telling the readers. Okay, by right, it's not unnecessary for you to have introduction in chapter 4, but just to make it interesting. Yeah, and then telling about the process, because he's doing gold nanoparticles preparation. So the gold solution was reduced to gold nanoparticle suspension when received electrons from sodium citrate. Okay, and then continue introduction of sodium citrate, the colored solution. Okay, blah blah blah. Okay, and then he start to talks about the results. The synthesized gold nanoparticles were then characterized by TEM, then UV spectra. So you can see that in this section, the results are actually TEM, okay, and UV. Yeah? To give evidence that he has obtained gold nanoparticles. Because when you say nano, it should be nano, right? And then the other evidence is UV spectra, because the UV has been done by someone else. So not to say it has to be 100% similar to the previous research, but there is a guideline at certain spectrum, okay, like this, saying that you have obtained gold nanoparticle, because you have observed this peak by other researchers quite some, I mean, there are many times that you achieve gold has the absorption spectrum at 520 nanometer. Okay, so if you have, let's say, 780 nanometer, then you should question your results. Not at the final stage when you write thesis, but at the beginning of your experiment, okay? So you should know already that you should obtain around 520. If you do not obtain 520, so let's say you obtain 720, then there's something wrong somewhere, okay? All right, so it's good also you have photos. I always encourage my student to make sure keep all the photos, whatever that you, it's not necessary that you're going to use it. It's not necessary, but let's just be safe. Keep the photos of your samples, good photos. You can see that TEM. So TEM here, sometimes we use HR TEM, sometimes we use TEM. Depends on whether you have whether you have access to HR10 or TEM. So when you present HR10, FISEM, the magnification is very important, because that is telling people how many times you have magnified the image, and then the scale. Okay, here you should know the scale. You should be able to, people from here could at least estimate the scale of nanoparticle here. Okay, so here means that we have a very well distributed nanoparticles formed from the process. So so this is by software itself. You don't have to plot. From the software you can obtain the diameter of the gold nanoparticle, and majority of the particles have around 21 nanometer. So that is evidence for the reader, telling that yes, he has obtained nanoparticles. Right. Now, what I want to highlight here again is caption. Okay. And another one is when you write chapter 4, we do not put the picture first before telling the story. Okay. You have to tell the story first. You can see here, we need to talk about the figure, just the one that I showed you just now. Talk about it before showing it. So do not put the picture first and then talk about it later. Okay, you have to talk about it a bit. It's okay if you want to extend after the showing the figures, but at least talk about it before you put the figure. And the figure should not be far from the discussion. The related figure should not be far from the discussion in text. So if it is figure 4.1, do not put on, this one is page 2, for example. So you do not put in page 6 or page 7 after your discussion. It should be close together. Yeah. And caption, you can see caption, the rules of writing caption. It has to be self-explanatory. What does it mean, self-explanatory? Whenever that anyone read caption with this figure, he or she does not have to refer back to the text. Okay, you just have to read the caption and understand the figure. Okay, for example, here, A, gold nanoparticle suspension synthesized. Okay, talking about the picture, the photo just now. And then B, TEM image of gold nanoparticle suspension at magnification 200K, kilovolt usually. And then absorption for C is absorption of the gold nanoparticle, okay? And then the histogram. So it has to be very detailed. The caption has to be very detailed. Self-explanatory, okay? The reader do not have to refer to the text above. All right, and of course, he started with synthesis and then followed by characterization. Definitely, in this case, he wants to combine silicon nanowires, gold nanoparticles to modify electrodes. Again, you can see that he starts with a sentence. So now he talks about the results. Okay. Okay, he talked about the introduction first. talk about the process of combining silicon nanowires and gold nanoparticle. You are allowed to have this, even though you, of course, discuss a lot in chapter 2. But you are allowed to have this, but not too much. Not too much on review material, because now you are not doing review, but just enough to help the reader to revise back. Okay, now in this section, there are certain observation has done by the previous researchers. Okay, and now he's trying to attract attention from the readers, talking about the materials that he used. So what is actually the results from here is not there. You can see that there is no results in this section. Okay, so it's like an introduction for the whole characterization. So you can see it's just introduction. 4.2.1 is more on introduction of the results for 4.2.2. You are allowed, because this is a story, but not too much. Okay, so when he started the characterization, again, he started with morphology. Okay, morphology is very important. Okay, because he wants to tell people that he managed to modify the surface of electrode. In this case, the electrode he used, the material is ITO. ITO is indium titanium oxide. Okay, so A, you can see bare ITO. B, with silicon nanowires and gold. C, okay, C was, okay, this one is different magnification. 10K, 50K, and 50K, and then what's the difference? Oh, magnification. Oh, it's 100. Okay, you can see that now there is a mistake. So this is 100 magnification. It's not 50. Okay, so when we read this caption and then look at the images, you know the information is complete. Okay, you're happy with it. Okay, oh yes, this is the difference, how it looks when you have different magnification. Okay, so now what you have is on the use of, instead of just now is ITO, this is SPGE, screen printed gold electrode. Okay, and also with silicon nanowires and gold nanoparticles. So so the morphology is different. If you can see that screen printed gold electrode, the surface is quite different with the ITO, because ITO is glass. And then when you have silicon nanowires and gold nanoparticles on top of the electrode, you can see that it's almost similar to the above, even though you are using different electrode. Okay, let's move on very fast. Again, a caption. Okay, so you can see that you can tell storytelling is hard to control the agglomeration of these kind of composites. Okay, because you're trying to tell what is actually in the picture. Okay, so you observe agglomeration. Okay, so you tell people why that agglomeration happening is difficult to control, and why it is attributed that this nanocomposite dispersion from form tend to evaporate and deposit. Okay, why? And then you want to talk about the porosity. All right. Okay, image J. Okay. So if you plan to use FISM, okay, you have to be able to use image J software. So these are things that you need to know, right? And then you have EDEX to analyze the percentage of the elements. It's not absolute value, but it's the percentage on the surface of the on the surface of the material that you are doing modification. So here give you evidence that you have silicon nanowires as well as gold on that electrode. Yeah? So very important to give evidence. Yeah? All right. So let's move on to, okay, I think after, okay, at the beginning, of course, this is what we want to talk to people before we talk about the application. Yeah. All right. So let's move on to a few things that I would like to highlight. Okay, for in this case, you have, let's say, this is what we call as CV, cyclic voltammetry. I don't know whether any of you has gone through electrochemical courses. So it's good is you have, let's say, to overlap a few graph, okay? You have to make sure that the color is very distinguishable between different graphs. So do not use almost similar colors to at least try to have colors that is distinguishable between those parameters. Okay, so you can see the caption is a must to have a very detailed caption. Okay, you can see the molarity is there, the pH is there. Okay, this is self-explanatory. All right. Okay. All right. Okay. So you can see that he add on the textbook material, what do you call that? The chemistry behind. Okay. Okay. Right. What time is it? Okay, 3:35. We just scroll until we found that any interesting to be discussed. Okay, whenever that you have equation, formula, equation, you want to write, so make sure that you also have numbering just like figures and tables. So make sure that you know how to use equation, how to write equation. So your figures must be very clear. Okay, again, the skills in drawing, very important. Okay. Okay. So now this one, just a moment, yeah. All right. Okay, this is very important. Okay, this is RSM. Okay, you haven't gone through. I don't know whether you know about RSM or not, but RSM is have to help you with the formulation. Yeah? Because sometimes you cannot do 30, 50 sets of experiment, but with the help of RSM, and then when you put in data, so you can generate more data to have an optimized formulation. Instead of doing 30 sets, 50 sets of experiment to get the trend, so RSM can help you. So what I would like to highlight here is whenever that you report data, okay, you should have statistical treatment. For example, at least standard deviation, okay, the plus minus. So if you have a bar chart, you should have error bar, as well as if you have graph, the line, the straight line. So if you can have it, you should have error bar for the data. Okay, this one just let's go through very fast because I'm not good in RSM. Okay. So you can see this is what I meant by error bar. Okay, this is for me a must. So showing that you have done replicates. So this is error bar for bar charts. If you have error bars, it is evidence that you have done replicates, not just single experiment, not just single measurement. Yeah. All right, let's move again. Okay. This is again RSM, so okay. So whenever that you have results and you want to make a comparison, and so in this case, he is trying to compare. Where is it? We move too fast. Okay. Okay, this is okay. Let's say you want to make comparisons with a quite number of previous research, then you can table it. You can talk about in text. Okay, you probably make comparisons with different previous research findings, but if you find it that the points that you want to highlight are very important, so you can make quite a number of comparisons and you can table it. In this case, he is trying to make comparisons for DNA probe immobilization, means that how do you optimize the immobilization of DNA on the electrode. Why is moving there? Okay, so there's quite a number of people who has done it, so he would like to highlight what people have done, how they do it, and how's their performance. Okay, so this is very important in thesis, because you want to make comparison with your results. Okay, then okay, this one try not to repeat. For example, if you have the same data in a form of bar chart, but you also put it in a form of graphs. Okay, try to avoid that, because we do not need to repeat the same data to be presented in different form, unless it is very necessary, very important to have it in that way. Okay, right? If you have it in bar chart form and it is enough, then you do not need to repeat it in graph form. Okay. All right. Okay. Let's quickly move. Okay, this is also a good one. Comparison of the important parameter that you find it very interesting and you wanted to compare it to many researchers that have done, but they have different approach. So should table it. Okay. Because if you put everything in text, sometimes the reader can be, very tired reading the text. Okay, right. All right, I think we just move on to that. So if you have any questions, just stop me, okay? I think this is the end for chapter 4. Okay, let's look at conclusion. References, corrections. Okay, need to open the conclusion.